Excavator. This machine is designed for moving, digging, and loading soil. The excavator moves independently within its working area. Excavators are used for digging trenches, pits, and foundations. It performs site grading and loads bulk materials. It is used for earthwork. Excavators have a very wide range of applications, using 3D graphics. In this video, we will look at a hydraulic excavator. Where does it get such strength and power? The operation of such an excavator is based on Pascal's law. Fluid pressure in a closed system is transmitted equally in all directions and generates great force. The source of all the excavator's power is its hydraulic system. The source of all the excavator's power is its hydraulic system. The hydraulic system is a key component of an excavator, ensuring its power, precision, and efficiency. The excavator's hydraulic system controls the movement of the boom, arm, bucket, and undercarriage. The pump converts the engine's energy into a flow of hydraulic fluid, which is directed through the distributor to the hydraulic cylinders and motors. The power of the hydraulic system allows the excavator to achieve incredible results in its work. Using its hydraulic system, the excavator can reach hard-to-access areas that no other equipment can. Imagine that an excavator encounters an obstacle in its path, a large boulder. Using its hydraulic attachments, the excavator can drive over this obstacle. The hydraulic power is sufficient for the excavator to lift its own weight and drive onto the boulder. In the same way, it can lower itself from the boulder to the ground. The obstacle has been cleared. Surprisingly, despite all its strength and power, an excavator is capable of performing very precise and delicate tasks. Let's look at an example that demonstrates the precision and accuracy of an excavator's work. Of course, only the most experienced excavator operators can perform such maneuvers. This is a matchbox. Let's open it and place it face up within the excavator's reach. An experienced operator will be able to close this matchbox with the bucket. This isn't a myth. There really are operators who can do this. So what is the secret behind how an excavator works? How is it designed? Let's take a look at an excavator with a pilot control system. There are too many hoses, but that's not even all of them. To make it easier to understand what each hose does, let's examine them individually. Hydraulic excavators with pilot control are equipped with several types of hydraulic pumps. Since the entire hydraulic system is divided into a power circuit and a control circuit, the The system consists of two main components: main, power, pumps. These provide movement for the working equipment, boom, bucket, tower rotation, and travel. The hydraulic pump creates pressure in the system. Oil flows into the hydraulic manifold, which directs the flow to the working components. Hydraulic cylinders actuate the boom, arm, and bucket. Hydraulic hoses convey fluid through the system, ensuring the movement of the mechanisms. Used oil returns to the hydraulic tank through filters. The pilot circuit of a hydraulic excavator is an auxiliary hydraulic system. It uses low-pressure oil to remotely control the heavy main spool valves of the distributor. This ensures smooth and precise control of the machine without requiring physical effort from the operator. It is usually integrated into the main pump unit. It generates a stable but low flow of oil at low pressure. The pilot oil lines to the joysticks are shown in red. Joysticks and pedals control units located in the cab. When the lever is moved, they open internal valves, metering the flow of pilot oil. The pilot oil circulates through the system or is shut off by a spool valve, preventing the high-pressure oil from actuating the working components. When the operator moves the lever, for example, to control the arm, the pilot oil flow moves the plunger in the spool valve and opens the high-pressure oil flow. The working oil flow presses against the hydraulic cylinder piston, causing it to move and forcing oil out from the opposite side of the piston. The expelled oil is directed through the circuit that has opened in the hydraulic distributor into the hydraulic reservoir, passing through a filter. If the control lever is returned to the neutral position, the high-pressure flow will cease, and the piston in the cylinder will stop and be held in that position. To move the cylinder piston in the opposite direction, the control lever must be moved to the opposite side. The oil will now flow through a different circuit, but according to the same principle. The cylinder piston will move in the opposite direction. The same principle is used to control the rotation of the excavator's swing ring. The swing ring is rotated by a hydraulic motor. It converts the energy of the high-pressure oil flow into mechanical rotational motion. In the most common control lever layout, the controls for the swing ring and the boom are located on a single joystick. The operator controls this joystick with their left hand. When the joystick is moved to the left, the platform rotates to the left. When the joystick is moved to the right, the platform rotates to the right. Hydraulic motors are used to move the excavator. Each track is equipped with a hydraulic motor. In our video, for example, one hydraulic motor is shown. The operating principle is the same as that of the swing hydraulic motor. The excavator is set in motion by moving the front arms forward and backward. Each arm operates independently of the others. This allows for turning while moving. It is even possible to drive the tracks in opposite directions to turn in place. Sometimes, for the operator's convenience, pedals are attached to the arms. When moving forward, the operator can control the machine with their feet. That wraps up our brief introduction to how a hydraulic excavator works. If viewers leave comments saying they want to learn more about hydraulic valves or hydraulic motors, we can make a video about that.